Hi class, welcome to section 9.3, double angle, half angle, and reduction formulas. So for sine, double angle sine, we have one formula, 2 sine cosine. For double angle of cosine, we have 3 different formulas. So you get to choose which one you want to use. It really doesn't matter. And for tangent double angle, we have one formula to choose from. Okay, let's look at the first problem. So they give us that tangent theta is -3/4 and that theta is in quadrant 2, and they want us to find the exact value of sine 2 theta. So let's start with drawing our angle in the correct quadrant 2. So here's the angle, quadrant 2. So you draw a perpendicular onto the x-axis, call the angle theta, label it appropriately, opposite over adjacent. So this would be 3/4, but you have to figure out which of the two values is negative. In this case, since you're going to the left, the negative is the 4. Since you're going up, the positive is the 3. Using the Pythagorean theorem, you will see that a squared plus b squared equals c squared. So we get 9 plus 16 equals c squared. C squared equals 25, which means that c equals 5. Once you have the 3 sides of the triangle, now you can go ahead and use the formula. Sine 2 theta is equal to 2 sine theta cosine theta. And now we can use the triangle to figure out the values of sine and cosine. Sine is opposite over hypotenuse, so that would be opposite over hypotenuse is 3/5. So we have 2 times 3/5 times the cosine, which is adjacent over hypotenuse. So that would be -4/5. And we evaluate that. If you evaluate that, you're going to get 2 times 3 is 6 times -4 is -24 over 25. And that is our final answer. All right, moving on to the next problem. So this is a verify an identity problem. So it looks like we can probably work on both sides for this one. Let's start with the left side, or let's actually start with the right side. On the left side, we can just rewrite that. As you can see, there is a double angle that we can substitute the formula. We can use a formula to rewrite the left side. So let's do that later. For now, let's expand out the right side. Because there's a square, that means we can multiply it out. So let's use the FOIL method to expand the right side. So if you do the first term, you will get sine squared. Outer, sine cosine, inner, sine cosine again, and finally last gives us cosine squared. All right, we can combine these like terms. As you can see, these two middle terms are considered like terms. So we can add those two together and add their coefficients. 1 plus 1 is 2. So we're going to have 2 sine cosine theta. And the other thing that I hope you all recognize is the fact that sine squared plus cosine squared is equal to 1. That's a Pythagorean identity. I hope you guys can recognize that because that comes up a lot in verifying identity problems. So you want to be familiar with that. So we got 1 plus 2 sine theta cosine theta. That's on the that's on the right side. And as for the left side, let me go ahead and erase here. Okay. On the left side, we can just use the formula that we know. The double angle for sine is 2 sine theta cosine theta. And then we have our identity on both sides. So we're done with that. All right, let's move on to the next page. Okay, so now we're going to move on to what's referred to as reduction formulas. These are important because you're going to go from second power trig functions to first power trig functions. And that's really important in calculus. When you're integrating, it's difficult to integrate powers higher than 1, but it's not so difficult to integrate powers of 1. So that's what these are important for. So for the first example, they're asking us to write an equivalent expression for cosine to the fourth that does not involve any powers of sine or cosine greater than 1. So we're going to use these power reduction formulas in order to get the exponent to be 1. Okay, so let's rewrite this to begin with as cosine to the fourth can be first written as cosine squared squared. Cosine squared squared is cosine to the fourth. And now we can use the formula. So let's use our formula that you see up here. All right, so it's going to be 1 plus cosine 2x over 2 squared. Okay, the first thing I'm going to do is I'm going to square the denominator, and then I'm going to pull the denominator out. So 2 squared is 4, so that becomes 1/4. And now I'm going to write the numerator twice because I need to expand it. Cosine 2x plus 1 times 1 plus cosine 2x. So I'm writing the numerator out twice, and I'm gonna use the FOIL method again. And the denominator, since I squared it, it became 4. I'm just gonna write it as a coefficient out in the front. So let's do the FOIL method first, outer, inner, last, and we will get 1/4 1 plus cosine 2x plus cosine 2x plus cosine squared of 2x. So an important note here is when you multiply cosine 2x times cosine 2x, you get cosine squared 2x. You're not multiplying, these are called arguments. You're not multiplying the arguments together. You're leaving the argument the same, and you're simply squaring the cosine squared. All right, now we can combine like terms. These two are like terms. So let's combine those two. 1/4 1 plus 2 cosine 2x plus, now what I'm going to do is I still have this term, which we don't want a power greater than 1. So we have to use the formula again with this term here. However, look at the argument. The argument is 2x, and the formula, so when you use the formula, you're going to have to plug in 2x in for theta. So in other words, it's going to become this. It's going to become 1, oops, let's use the same color as I was using. It's going to be 1 plus cosine, instead of 2x, it's going to become 4x all over 2. So hopefully everybody sees what happened. Because the argument is 2x, when you plug it into the formula is 2 theta. So this is your theta. So when you multiply the theta times 2, you get 4x in this case. All right. The last thing we can do is we can split this fraction up into two separate fractions, 1/2 plus 1/2 cosine 4x, and then we can combine the 1 and the 1/2 together. All right, so we're just simplifying at this point. So let's go ahead and simplify a little bit more. We have 1/4 1 plus 2 cosine 2x plus 1/2 plus 1/2 cosine 4x. So as you can see, what I did here was I split up the 1/2 and the 1/2 cosine 4x. Okay, and then the final thing I'm going to do is just combine these two like terms, 1/2 plus 1. So 1/2 plus 1 is 3/2, and that is our final answer. Okay, so that will do it. That is our final answer here. Okay, now as you can see, you have you don't have any terms with the exponent greater than 1. This cosine has an exponent of 1. This cosine has an exponent of 1. All right, let's move on to the next type of formulas that you will see. These are called half-angle formulas. Half-angle because it's got an alpha divided by 2, which is a half angle. These are good when you're trying to find exact values of angles that are something like 15 degrees or 22.5, because these angles are not special angles on the unit circle. However, if you double them, 30 degrees, 45 degrees, they do become special angles. So we're going to use these formulas in order to be able to find the exact values of these type of angles. All right, notice that the sine is minus, the cosine is plus, and the tangent, there's 3 different ways you can write the tangent. I do recommend the third one, this one here. All right, it's just easier to simplify. And the plus minus depends on the quadrant in which the half angle falls on. So you will see that. Let's go ahead and try a problem. Go back to refer to it. There it is. I recommend the last one of the 3. You could use the middle or the first. This one turns out the easiest to simplify. So 1 minus cosine of... Okay, so the first problem that we have is finding the exact value, which means you don't want to use your calculator because the calculator won't give you an exact value. It'll simply give you an approximation, which is not something we want here. Okay, so to figure out what alpha over 2 is, well, we know what alpha over 2 is. It's 15 degrees. This is alpha over 2. All right, then you solve for alpha by multiplying both sides of the equation by 2. So alpha is equal to 30 degrees. So now you can write the problem out this way. The sine of 15 degrees is equal to the sine of 30 over 2, where alpha is your 30-degree angle. All right. And if you look back at the formula, it says plus minus square root 1 minus cosine alpha over 2. Alpha is 30, remember that. Okay, now we have to figure out whether it's plus or minus. It's not both. It's not like the quadratic formula where there's 2 answers. It's one or the other. In this case, 15 degrees is in quadrant number 1, and we know that sine is positive in quadrant number 1. So therefore, this needs to be plus, not plus minus. Now we can erase the plus minus because we know it's positive. Once again, because 15 degrees is in quadrant 1, and sine is positive in quadrant 1. That's why we can remove the plus minus. All right, if you look at your unit circles, cosine of 30 degrees is radical 3 over 2. So let's rewrite this problem out. Square root 1 minus square root of 3 over 2 over 2. Since we do need to combine these two numbers together, we can rewrite 1 as 2 over 2. That way we have a common denominator. And now you can rewrite that as 2 minus rad 3 over 2 over 2. And in this type of situation, when you have a fraction divided by a whole number, you simply have to just multiply these two denominators. So 2 times 2 is 4. So now we have square root of 2 minus rad 3 over 4. Okay, now we can break up the square root into the numerator and denominator. Square root of the numerator divided by the square root of the denominator. The square root of 4 is 2. So because the square root of 4 is 2, that just becomes 2, and the square root is only in the numerator now. And that is our final answer. Okay, moving on. Let's look at another type of problem here. Okay, it says given that tangent alpha is 8/15, alpha lies in quadrant 3, find the exact value of those two half-angle trig functions. Okay, so let's do that now. Okay, first things first, we must draw the triangle in the correct quadrant, which is given to us. So that would be quadrant number 3. There's our alpha. Draw your triangle. Okay, tangent is opposite over adjacent. Okay, so we have 8 over 15, opposite adjacent. However, we're in the third quadrant. Both of those values need to be negative, negative, negative because of the third quadrant. And that should also make sense because negative 8 divided by negative 15, double negative becomes positive. Now we must do the quadratic formula to find the hypotenuse. So a squared plus b squared equals c squared. We have 64 plus 225. We have c squared equals 289. Square root of 289 is 17, so that's our hypotenuse. Okay. So let's start with cosine of alpha over 2. Cosine alpha over 2 is going to be plus minus the square root 1 plus cosine alpha over 2. That's the half angle formula on the previous page. Okay, let's figure out whether cosine alpha over 2 is positive or negative once again. Okay, so in this case, what I would recommend, we need to figure out whether this is plus or minus. We know we're in the third quadrant, so this is what I would do. So let's do it this way. Since alpha over 2 is in the third quadrant, that is, okay, actually we can just look at that and determine cosine is positive or negative. Oh, wait, no, we want alpha over 2, not alpha. So we do have to do this. We know alpha is in quadrant 3, right? That's between 180 and 270. Here's 180. Here's 270. That's where alpha is between. But if you divide everything by 2, you get 90 alpha over 2. And half of 270, I believe, is 135. Okay, so there you go. Alpha over 2 is between 90 and 135. That would be in quadrant number 2. So quadrant 2, because 90 degrees is up here. 135 is somewhere over here. And so that's quadrant 2. And we know cosine is negative. Cosine is negative in quadrant number 2. So therefore, this must be negative. Okay, so this should be a negative. All right, so now we can go ahead and, for some reason, it's not erasing, so I'm just going to scratch out the positive because it's not erasing on my screen for whatever reason. Okay, so let's go ahead and evaluate this. Okay, so we know that it's negative 1 plus cosine of alpha, according to our triangle that we drew, is adjacent over hypotenuse, which is negative 15 over 17. Okay, so that's going to be negative 15 over 17 over 2. We can change 1 to be 17 over 17. And that becomes negative 2/17 over 2. All right. And in this situation, you get the 2's to cancel out. So it's just going to be 1/7. The square root of 1/17, which is square root of 1 is just 1. And there you go. 1 over the square root of 17. You could rationalize that denominator if you would like. Let's do that. So rationalize the denominator, multiply it by square root of 17 over 17, and you do get negative square root of 17 over 17 as our final answer. And that will do it. Okay, we do have one final problem, and that's the tangent. Here it is. The tangent, the half angle for tangent. So let's do that now. Okay, the good thing is we already have the triangle drawn out, so that makes things easy since we've already done that. Okay, so tangent alpha over 2 is equal to, if you forget the formula, the sign, 1 minus cosine over sine. we know that the cosine of alpha, according to our triangle, is adjacent over hypotenuse. So negative 15 over 17. Careful with that double negative. And sine is opposite over hypotenuse. Okay, so there's our opposite over hypotenuse. This double negative becomes plus. We have 17 seventeenths plus 15 seventeenths over negative 8 seventeenths. Okay, so that's going to be 32 seventeenths times the reciprocal. The reciprocal is negative 17 over 8. 17s cancel. 8 goes into 32 4 times. So our final answer is negative 4. And that completes this problem. And actually it completes this section. So we are done.